Welcome. I am continuing same set of questions. See, two blocks are there. Last time I called A and B. This time 1 and 2. Question 57. See, two blocks 1 and 2 are connected by a cable which passes over a frictionless pulley. I told you, frictionless pulley, smooth pulley, frictionless hinge, smooth hinge. In all the cases, tension T remains same. Okay. See, this way. But one small change I made now. See, last question, this cable was here placed parallel to this plane. Here it was placed parallel to this plane. Last question. So, in the previous question, see, this T was along the plane, this T was along this plane. But this time, see, the cable is inclined here. See, here it is parallel to, by sketch you can make out. See, no data given means understood. This is parallel to this plane. But here, it is little some stiff. Come see, it is attached somewhere here. So, angle given with horizontal, see, you can make out. With horizontal, this angle is 42 degrees. One small change I made, so that little more work is there. Okay, then, as shown in figure, now, last class question was, see, I already explained last class. Today, both the question 57, 58, I will finish little fast and then I will close the class. Anyway, two questions per class, all this friction problem, maximum. See, last class, I will tell you what was last class question. That is question number 55 and 56 are, see, P this way. What force to be applied to this side block, right side block, once find the force P to prevent this block from sliding down. Then second question was 56 question, what force P required to move it up the plane. So one of the question, the purpose of P is preventing this one from sliding down. Next question, purpose of P is to move it up the plane. Now reversed. Now I am applying P on this side block. So again same two questions. First question, see, 57. Find the value of P when the block 2 is on the verge of sliding down the plane. What force is required here this way so that this is on the verge of sliding down. Or you can make a note. Instead of asking what force of what, find the value of P when the block 2 is on the verge of sliding down, they can also ask what is the least force required to prevent the block 2 from sliding down. Both are same, I told already. So now, not much here. See, if the P is not there, what will happen? Block 2 will slide down. Why? Question is that way, because you can make out stiff angle and heavy weight here. See, if the P is not there, block 2 will slide down. When block 2 slides down, block 1 will move up. Remember, when block 2 slides down, block 1 will move up. Therefore, when you consider equilibrium of block 2, see here, block 2, it will try to slide down, friction is up. See here, up. Whereas, when you consider equilibrium of block 1, when that is sliding down, this will move up, friction is down. See here. This all I explained last time. Okay, now, once you write the question, when you start solution, write let T be tension in the cable, which remains constant. It is better to show it once. See, show it, show the tension this way and this way. Show it. If this is T, this also T. Write one more sketch and show the tension. Or understood. When you consider equilibrium, even if this is not written, you should remember one thing. When the connecting member is in tension, it will pull the member connected. See, it will pull, see, what will happen? This tension, see, when you consider block 2, if this is tension, it will pull it here also. Later, block 1 also, it will pull it. This is all I told you. But anyway, better. Or in the question only you can make out. They are not giving it. T, we are deciding. Okay, start. Now, last time, see, your P was here. Unknown was less there. See, last time P was here. unknown more here, but this time unknown is less for block 2, more for the block 2 unknown is T and R, because friction is mu R. Here unknown is T, R and P. So 3 unknown for 1, 2 unknown for 2, or first consider equilibrium of block 2, or easy way, where unknown is there, don't consider that block, consider the other block first. Okay. Consider equilibrium of block 2. Now, one thing I forgot, you should write, not forgot, I not told is limiting friction. Therefore, everywhere frictional force equal to mu into normal reaction. So here mu is for block 2, see mu is 0.4, 0.4 R2. Later here frictional force mu is for block 1, mu is 0.3, so 0.3 R1. This if I explain further, you will feel this person is wasting the time. Okay, start. Now first consider block 2. See, this is XX, this is YY. Sigma Fy0. Once again, see, if this is 50 degrees, this is 40 degrees. So with respect to 40 degrees, cos sine. Y means, sorry, now I cannot tell why it is cos sine. Too late. Okay. Sigma Fy0, sorry, Fy0 plus R2 minus 450 sine 40 equal to 0, you get the value of R2. Sigma Fx0. Take this side positive, see, right side, somewhat right side. This I written here, this way positive. So, minus T minus 0.4 R2 plus 450 cos 40, this is not there, equal to 0, you get the value of T. Actually, this question is same as last class question. Unknown place is interchanged, so just to practice over. Now, consider equilibrium of block 1. But one important now, see, when you consider equilibrium of block 1, force P is here along the plane, weight of how much? 250 Newton down. If this is 30 degrees, this is 60 degrees, so cos sine is clear for you. R1, and I already told you, when this is sliding down, this will move up. Friction is down. This I told you. Now very important, see, this cable is inclined to, it is not along the plane here. It is making angle of 42 degree with horizontal. See here, this inclined plane is making 30 degree with horizontal. See, correct, clear. The inclined, I should not explain this one. Very simple language here. This inclined plane somewhere here, inclined plane, this inclined plane is making 30 degree with horizontal. It is making, see, 30 degree. Whereas the tension T, see, the tension T here is making how much? 42 degree with horizontal. Therefore, angle made by tension T with the plane will be 42 minus 30, that is 12 degrees. High school level mathematics. So 12 degrees, you have to confirm it. See, last time question, there was no 12 degree. This T was along the plane. So no resolution required. So this time, with respect to 12 degrees, cos sine. Okay, question is over. Sigma F, in case any calculation mistake is there, correct it. Don't make an issue. Sigma Fy0, I will take this side positive. See, then plus R1 minus 250 sine 60, then see, not over, plus 229.018 sine 12. This term was not there last time because last time it was along the plane. Okay, you get the value of R1. Because once you get T here, when you go to next block, enter the value of T. T, see, when after you finish block 1, 2, when you go to block 1, T value is known. Then sigma Fx0, take which way? This way positive, right side, this way. You get minus P minus 0.3 R1 plus 229.018 cos 12, and then not over minus 250 cos 60 equal to 0, you get the value of P plus 48.505 Newton. So if you apply a force of 48.505 Newton, this block is on the verge of sliding down. Since it is sliding down, friction is up here. See, for this block 1, friction is, see there, friction is, this block 1 is what? On the verge, when you, if you apply, if you apply a force of how much? To 48.505, not block 1. Block 2 is on the verge of sliding down. Block 2 is on the verge of sliding down means friction is up. When block 2 is on the verge of sliding down, block 1 is on the verge of going up. So friction down. Now this question is 57. Now 58, I will tell what will happen. See, 58. Same question. Two blocks 1 and 2 are connected by a cable which passes over a smooth pulley. Everything is same, no change. I am not changing data. Same arrangement. But one small change I am making now, just to understand, see, I will make the P slightly inclined. Okay, I don't know whether space is there or not there. I'll check the camera. See, with the plane, the P is making inclined. Little work for you. This is the P. With the plane is 30 degrees. Okay, P is this way. With the plane, it is making an angle of, say for example, some angle given here. Sketch is not fully clear. This is 30, 18 degrees. 18 degrees. Okay. This P is making an angle of 18 degrees. See, I have checked the camera now. I want change I will make so that little more work is there. Okay. This P is this way. Okay. Now, just I will check the camera once. Okay, perfectly okay. Okay, one small change I made. Okay, now I will tell you what happens now. See question. Find the value of P when the, now this time I will make one more change for you. Instead of this way here, mu, I will write here, somewhere here, mu equal to 0.25. See, in the question given or in the words, you can do one thing. If you don't like in the question, you can write, find the value of P when the block 2 is on the verge of moving up the plane. Reverse up the plane is the question. And then you can write here. If you don't write here write coefficient of friction is 0.25 for both contact surfaces. It does not matter. Last time, see, you took 0.4 here, 0.3 there. It hardly matters. You take both the places 0.25 now. So now this will become, see later now, this will become 0.25. I will forget later. This also will become 0.25. 0.25. And one more thing, the P will be not be like this here. See, this P will be now, when I take next block, I will change now only. It is this way. P is here, see, little bigger, okay, so that I can resolve it. Okay, this is the parallel line along the plane, parallel to plane. This is your P. P, it makes an angle of how much? 18 degrees here. Therefore, later when you resolve, what will happen? With respect to 18 degrees, see, this is cos, this is sine. P, this is P cos 18, P sine. You should not do this way. And now, the most critical part is important now. See, I will explain now. Other things I will change later. See, numerical solve I will change later. Now, the most important is find the value of P when the block 2 is on the verge of moving up the plane. Now you are applying heavy force here, so that now you have to increase the force. This block 2 has to move up. Since the block 2 is moving up, friction is down. See here, this friction will be down. That's very, very important. That's why this question is given, to correctly understand direction of friction. See, down. And when the block 2 is moving up, when you apply force this way, block 1 will come down. See, as you apply the force this way, here this way force, block 2 will move up, friction down. But block 1 will come down. When block 1 comes down, friction is up. Okay. See, you cannot do this way. You have to write one more sketch. You don't do this way all. Okay, now I think everything is clear here. See, this 42-degree remains same. Or I can make this one inclined here. No, let it be 42 degrees, no problem. Last time it was parallel here. Okay. Now see, I will explain once again. This P is not along the plane, slightly tilted here at 18 degrees here. See, later with the plane 18 degrees. So since you are measuring the angle with the XX, see, parallel to XX, cos sine with respect to 18. I will not explain once again. And lastly, I will tell, last time you are applying the force P here to prevent 2 from sliding down. So if you remove P, 2 will slide down. So for 2 slide down, friction was up. When that is sliding down, this will move up. There, friction is down. But this time, P is such a force so that block 2 will move up. When block 2 moves up, friction is down. And when block 2 is moving up, block 1 will come down. So friction is up. Over. Now I will change the numericals and continue. Okay, I changed all the numericals. See correctly now. Sigma Fy0 plus R2 minus 450 sin 40 equal to 0. R2 will come. Sigma Fx0, this side positive, minus T plus 0.25 R2 plus 450 cos 40 equal to 0. Substitute for R2, you get T. That T you have to enter when you go to next part. Okay. Consider this one. Everything I explained regarding friction, all explained. Okay. Sigma Fy0 plus, I will start from P first. Why? Unknown is important is P. See. Plus P sin 18 plus R1 minus 250 sin 60 plus 417.033 sin 12 equal to 0, 1. Equation number 1. Sigma Fx0, take right side positive, minus P cos 18 plus 0.25 R1 minus 250 cos 60 plus 417.033 cos 12 equal to 0. You get equation 1 and 2. Solve it, you get P. R2 is not required. Okay, now this will complete today's 2 classes. Now what I will do is, some more questions are there. I will give one small recap for you now. See, recap regarding FF limit direction. That will be the last time I will tell. Because now onwards, I cannot explain the same thing. Recap is not required. For the question number, this is today 57-58. Last time 55-56. Today 57-58. For all these 4 questions in the board, dividing into 4 parts here, I will give you recap for you. So that in future, I need not explain that much for frictional force. Okay, now lastly, before I conclude the class, see, two blocks connected by cable, one on this side plane, one on that side plane. Last class question 55. Last class question 56. This was last class. Today's class 57, 58. See, angle all I will not show. That all not important now. See, even one cable given this way, that all you account it. Trigonometry or geometry. Not trigonometry, geometry only. But important is regarding frictional force. See, I put FF limit. See, I written here. See, RA, block, last class I took block A and block B. Today's class I took block 1 and block 2. So, today's class R1, R2, R1, R2. Last class RA, RB, RA, RB. Okay, then all the four cases, tension is T. Tension is T. That is already known for you. Everywhere, weight acting down. Weight acting down. And question is, see, last class question 55 was P here. Again 56, P here. Little inclined I given. Okay, so that resolution is there. Or they can give like this also. Last class 55 and 56, P applied to right side block. Don't by heart AB. Right side block. Today's class, both the question, P applied to left side block. See here, P how much? Question is, what is P? Purpose. See correctly, last class, this P applied, see this way, okay, P applied. 55 question is to prevent block A from sliding down. That means if this P is not there, block A will slide down. So to prevent it, this should be, so to, our question is what? Either to prevent block A from sliding down or least force required when the block, least force required to prevent it from sliding down, or when block A is on the verge of sliding down. So here, block A on the verge of sliding down. But here, not that way. See, one particular force you apply, see, you can somehow manage to hold there. You should not allow it to slide down. Second question is not that way. You apply more force so that block A will go up. Block A will go up. See, here block A, tendency is to come down. This way, tendency. I use green color for understanding. See, block A, you write here, tendency is to what? Is to slide down. But here, block A, tendency is to go up. This way. Today's class 2 question, force applied here. One question is P to prevent block 2 from sliding down. So if you remove P, block 2 will slide down. So its tendency is to go down. Second question, what, see one particular P, you can prevent it from sliding. But if you increase the P further, it will slowly start moving up. So second question, to move the block 2 up the plane, tendency is like this, see, going up. Remember, friction is always in opposite direction in which the body tends to move. See here, once again, apply a force P to prevent block A from sliding down. So tendency of block A is to slide down. Since it is to slide down, the friction force is up here. See, FF, limit for A. How much not required. But remember, when this is sliding down, very important, when this block is sliding down, that block will move up. Therefore, see, this block, when it slides down, then that block will move up. So friction here is down. FF limit for B. Come to this question. The force P will see that block A is on the verge of moving up. When block A is on the verge of moving up, friction is down. FF limit for A. See, it is opposite. And when it is moving up, block B has to come down. Since it has to come down, friction is up. FF limit for B. Okay. Today's class purpose is to see what happens to 2. What force is required to prevent the block 2 from sliding down. So if this P is not there, block 2 will slide down. See, tendency is to slide down. This is a tendency. When it slides to slide down, friction is up. FF limit for block 2. Now, when it slides down, this will go up. So friction here is down. Opposite. FF limit for 1. This question, what force is required to move the block 2 up the plane? So tendency is to move up. When tendency is to move up, friction is down. See, these are tendency. FF limit for 2. When this is moving up the plane, this force, see that this will come down. So when it comes down, friction is up. See, tendency is to come down, so friction is up. FF limit for 1. So very carefully, see, lastly I will tell. First case is, this question is last class, first question 55. We want block A is on the verge of sliding down, friction up. When it is sliding down, this will move up, friction down. Second question last time was block A moving up, so friction down. When the block A moves up, block B will come down, friction up. Today's class, your P is so that block 2, right side block, is tendency to go down, sliding down. So friction up. When friction is up, see here, when this is what? When it is trying to slide down, this will move up, friction down. Next question is force P when block 2 is on the verge of moving up. When it is verge of moving up, friction is down. When it is moving up, this has to come down, friction is up. So therefore, be very careful. Or see, tendency is to go down. If this tendency is to go down, see, friction is always opposite. See, this tendency to go down means this tendency to go up. That's why, see, tendency down, friction up. Tendency up, friction down. When this tendency is to go up, this tendency is to go down. Tendency up, friction down. Tendency down, friction up. When this tendency is down, this is up. Tendency down, friction up. Tendency up, friction down. Here, tendency is to move up. Tendency up, friction down. If that is, then that is up tendency. This is down tendency. Down, friction up. I already explained. I thought to once for all remove the confusion. So anybody who got confusion about friction, go through this final explanation given now. I forgot to tell there. I should have told one thing there. I will write in the description. I may write what you do is, if any doubts are there regarding friction, see the end of the class. Okay, or I may add it. But no, people who see the entire class, they will come here. People who have no patience to the entire class, I am not bothered about them. See, I told, if you cannot see my entire class, you think you know too much, then you know too much. Okay, don't learn from me. You will learn from me. Remember, you have to surrender to me. I tell everybody in the offline class, first, see, a student first has to surrender to the teacher. Surrender means what? Yes, sir. You know everything, I know nothing. Then only he will learn. Thinking that I also know, that tendency is not good. But what happens sometimes is person who is teaching gets confusion. That I don't know. I can't help it. But if the one who teaches, if you have got confidence in him, and if you think that he is much above me, then do one thing. You imagine you are not knowing anything. Let me go through each and everything he is going to tell. Okay. That's all. Thank you. We'll meet in the next class.